Well, here we go again, and we are about to finish up our series on bonding. And over the last couple lessons, we have talked about Lewis structures for molecules, and we want to continue with that. And let us start with this. Consider the polyatomic ion phosphate, PO4 3-. Draw the Lewis structure for this polyatomic ion. And where do we always begin? We start with counting our valence electrons. So we look on our periodic table. Let's find phosphorus. Where's phosphorus? Wow, what a mess that is. Okay, where's phosphorus? Here is phosphorus. And so that would have what? 5 valence electrons. And here's oxygen. It has 6. So, okay. So phosphorus 5, oxygen 6. Good. So here we go. 5 valence electrons. And then I have 6 for oxygen, but I have 4 of those. Good. What do we do with that? What does that 3- mean? Well, what does that mean? A 3- means that there are 3 more electrons than protons. So that means we have to do something with our valence electrons. Okay, so let's go back to our notes here on Lewis structures. We have to make a little addendum here under number 1. Count valence electrons in compound. And what we're going to do is add electrons for a negative charge and subtract electrons for a positive charge, or what we call what? A negative ion or a positive ion. So if we have a negative ion, we're going to add electrons. If we have a positive ion, we're going to subtract electrons. Okay, good. Here we go. We have what? I have a negative ion. There's 3, so that means we want to add 3 more electrons to this. So what do I get? 5 plus 24 plus 3, that looks like 32. So I have 32 valence electrons I need to put in my picture. We need to choose a central atom. How about phosphorus? We want to surround that with my oxygens, right? We want to complete our octets. This is 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8. Good. Now let's count our phosphorus. How many does phosphorus have? 2, 4, 6, 8. Yeah, good. So now let's count our total electrons. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. So I have 32 electrons in my picture. How many was I supposed to put? 32. Now we do one last thing to make this completely correct. Since this is an ion, we need to tell the audience, the reader, that we have added electrons. And the way we do that is we put it in brackets and we put the number of electrons or the charge in the upper right-hand corner. So that is the way we would do phosphate. Good. Here you go, your chance. Put me on pause, bring me back when you want to see the answer. Great, here we go. I have to figure out what? Valence electrons. My nitrogen has 5, my hydrogen has 1. What does the plus mean? It means I have lost an electron, so that means I'm going to subtract 1 electron. So I have 5 plus 4 times 1 minus 1, and that is equal to 8 valence electrons. I'm going to put nitrogen in the middle, surround it with my 4 hydrogens. Check for octet. Aha, my hydrogens don't need octets. My hydrogen need 2, right? Okay, so there's 2 there. There's 2 there for that hydrogen, 2 for this hydrogen, 2 for that hydrogen. My nitrogen has 2, 4, 6, 8. So the nitrogen has an octet. That looks great. How many electrons in my picture? 2, 4, 6, 8. 8 electrons in my picture. It is an ion, so we put it in brackets. And what's its charge? Positive 1. So there we go. It would be like that. Beautiful piece of cake, right? Going forward, I'll let you try one more. Here you go. This is a tough one. Draw the Lewis structure for nitrate. Pause me and bring me back when you're ready. All right, here we go. Nitrogen is 5, oxygen is 6. We have a -1, so we're going to add 1. So it's 5 plus 3 times 6 plus 1, 18, 22, or 23, and that equals 24 valence electrons, right? 18, 20, I think that's right. We're going to put nitrogen in the middle. We're going to surround it with oxygens. Oops. Okay, we'll do it this way. Now what do? We want to expand, we want to complete our octets. 1, 2, what's 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. How many electrons are on my nitrogen? 2, 4, 6. So we need to put 7, 8. Good. Now what do? We have to count. 2, 4, 6, 8. 10, 12, 14, 16, 18, 20, 22, 24, 26. So I have 26 valence electrons in my picture. Uh-oh. I have 26 valence electrons. How many can I have? 24. Egads. We have to do something differently. And what must we do? Well, let's go back and look at our notes. Okay, some number of electrons. If the same as the number, then you are done. Guess what? We're not done. Why? Because it's not the same. So, what if there are more electrons in drawing than there are in our valence count? What do? We have to start over. That's why I said we should use a pencil sometimes. Start over and use double bonds or triple bonds as needed. Okay? All right. Doink. So now we go back here. We had too many electrons here, right? I had 26 in my picture. I only have 24 that I'm allowed by my valence electrons. So that means I have to do what? Start all over. Oh, man, I hope I wasn't using pen. Nitrogen, oxygen, oxygen, oxygen. Oops, but now what did I say to do? Try a double bond somewhere. Where should I put it? You can put it anywhere except for hydrogen. Cannot use a double bond. And we're going to double bond off our central atom, so I'm going to just choose this one, this oxygen here. Now, complete our octets. I have a 2 here, right? So I need 4, 6, 8. Let's make that electron nicer. I have 2 here, so I need a 4, 6, 8. Now, I have a double bond here. How many electrons are in a double bond? 4 electrons are in a double bond. So that means I already have 2, 4, 6, 8. Good. So now let's count up all of my electrons. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. I have 24 pictured here. How many electrons are on my oxygens? 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. How about my nitrogen? 2, 4, 6, 8. Good. So that would be correct. Let me draw this a little prettier, right? Oxygen, oxygen, oxygen. Complete my octets. Put it in brackets because why? Because it's an ion. And there we go. And that would be a correct, this is a correct drawing for nitrate. Now, you might say, Mr. Smith, could I draw that another way? Sure you could. You could have the double bond going to the oxygen on top, right? And really, it's the same picture. We're just rotating it. But you could certainly draw it this way, right? Or you could draw it another way, right? We could put it this way and say, I'm going to put the nitrogen here, double bond this, this, and this. Good. And so you really could choose any one of these. And if we were going deeper into chemistry, we'd say that nitrate is a resonance structure, but we won't go there. Either one of either one of these would be considered a correct Lewis structure if someone just says, hey, draw a Lewis structure for nitrate, and they don't tell you it's a resonance structure. Okay, good. Here you go. Another, consider um, ethene, C2H4. C2H4. I'm going to give you a hint here. The two carbons are bonded together, and then you have hydrogens on each carbon. Okay? You guys give this one a shot. Bring me back when you're ready for an answer. Okay, so carbon has 4 valence electrons. Hydrogen has 1, so I have 2 times 4 plus 4 times 1. And that's 8. That equals 12. So I have 12 valence electrons, right? I'm going to start with, I need a central atom. And actually here I have 2 central atoms. I told you my carbons are bonded to each other. And then let's go with a little symmetry and put 2 hydrogens on each of these. Good. Now what do we want to do? We want to complete the octet. All my hydrogens have 2 electrons already. What about my carbons? Well, this carbon has 2, 4, 6, so it needs 7, 8. And this carbon has 2, 4, 6, 7, 8. Now let's count our electrons. 2, 4, 6, 8, 10, 12, 14. I have 14 electrons. Oops, we have a problem, right? So what do we have to do? When I have too many electrons, I have to start over and use a what? A double bond. That is correct. So I'm going to take my carbons and double bond them. Remember, you cannot double bond hydrogens. Hydrogen, 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 hydrogen. Good. Each of my hydrogens has what? 2 electrons. How about my carbons? Well, it has 2, 4, 6, 8, and this carbon has 2, 4, 6, 8 electrons around it. Let's count. 2, 4, 6, 8, 10, 12. I have 12 electrons. How many am I allowed? 12. So that would be my correct Lewis structure for ethene. Ethene, I hope I said ethene. Ethene. Oops. No A. Ethene. That's this thing here. Good. Moving on to our last picture. Yay! And we are done with bonding. All right. This one's a little difficult, and we'll work through it together. I shouldn't say it's a little difficult. It's just a little different. Remember, okay, first thing, we'll start counting our valence electrons. I have 4 from carbon, 3 times 1 for hydrogen, 6 for oxygen, and 1 for hydrogen. Add those up, and I get 7, 8, 14. You guys agree with me? I have 14 valence electrons. Good. Now, choosing the central atom. Wow, we have a whole bunch of things here. Well, first of all, we can say we know it's not hydrogen because hydrogen is never the central atom. And remember, I said sometimes they give us a hint based upon the formula. So what they're telling us here is, look at it. We have 4 hydrogens, but they're not together. And they're telling me that these 3 hydrogens are bonded to this carbon, and this hydrogen is bonded to this oxygen. So that means I'd have C with an H and an H and an H, and I'd have an O with an H, and then what must be true about the C and O? They must be bonded together. And we get that by looking at our formula here, okay? That's how we get the hint. Now, let's do everything else. Let's complete our octets. My hydrogens are fine. This carbon has 2, 4, 6, 8. The oxygen has 2, 4, so I need 6, 8. And now let's count up all of our electrons. 2, 4, 6, 8, 10, 12, 14. I have 14 electrons in my picture. How many am I allowed? 14. So that is a correct picture. Let's draw that again without all the checks. There we go. That is what we would call methanol. Methanol. The OL means that I have this thing here, which we call an alcohol group. Alcohol group. When you have an OH like that on the end of a carbon, we call that an alcohol group. You don't need to know that, but this you do need to know. There we go. We are done. So next time we're going to get into some molecular geometry and something called VSEPR. Good. And so it goes.